Good morning. So far we have studied in the first module the free vibration analysis, and now we are going to study about force vibration analysis. And here some differences between this static and a dynamic problem is given, which we have discussed. Now let us coming into the type of dynamic loading. What are the different types of load? So far we have studied about SDOF systems. Now we are studying about what? SDOF systems. SDOF. What is SDOF? Single degree of freedom systems. And in that there are two conditions. That is, one is free vibration and other is force vibration. So free vibration again of two types, damped, and that is with the C is equal to 0 and with the C not equal to 0. Now we are going to study about forced vibration. So here general condition was f of t is equal to 0. That was our condition. Now here in this forced vibration, you can see that there are some types of load. One is periodic loading. That is, a time variation of load is same for successive number of cycles. So here you can see, here this is one cycle. This is one cycle. After that and next cycle. So the same type of loading is there. Such a loading is known as periodic loading. The simplest periodic loading is a sinusoidal vibration. Sinusoidal means a load which is having, for example, P0 sine omega t. This is a simplest type of load. That loading is given here. Then first one is complex than the second one, and here the rotating propeller of a stem of a ship, rotating machine in a building, etc. are examples of these type of periodic load. Okay. And then next type is non-periodic. That is a blast or a explosion or a earthquake. That is, time variation of the load is not same for the successive number of cycles. So here you can see, if we are looking here you can see here the loading is very small, then it is increasing, then it is decreasing. Likewise the load. So this is a basic example is earthquake or a blast or an explosion. So that is an example of a non-periodic loading. Force vibrations, that is in force vibration, so two types of loading are there. One is periodic and another is non-periodic. Now force vibration, if the external force is considered to be operative during the vibration of motion, such a motion is known as forced vibration. That is, we are considering external force. That is, the equation will be mx double dot plus cx dot plus kx is equal to f of t. So this f of t can be periodic or non-periodic. Applied force or the displacement excitation may be harmonic, non-harmonic. So this force can be different types. One is it can be non-periodic, non-periodic, random, etc. When the applied load varies as a sine or a cosine function, it is known as harmonic loading. And when if the load is in the form of P sine omega t or P cos omega t, such a loading is not harmonic loading. So now onwards we will be studying about force vibration, and in this first module we have to study about this harmonic loading. What is the response? That is, we have to find out the equation for x. That is the thing which we will be studying. So the external forces, it can be harmonic, impulsive, periodic, and general loading. Harmonic means it is P0 sine omega t cos omega t, that loading. Impulsive means, for example, it can be a constant load or it can be a rectangular load, likewise. Now we are going to study about our main focus is about harmonic loading. So here you can see the harmonic loading can be sine loading and cosine loading. Sine loading means it will be f sine omega. This is a term only, omega f, just denoting. So it is the form of a sine omega t, or it can be in the form of a cos omega t. So the loading will be like this. Okay. Now this is the loading. The loading will be like this. Now let us consider a forced vibration system which is subject to a harmonic loading, and here we are going to consider the load sine. With respect to sine wave, we are going to find out the response and all. So here this is the, what is it is called? It is a simple dashpot model. A mass will be there, stiffness will be there, then damping will be there. So the parameters of a, as well as the loading will be there, external load will be there. So this is a free body diagram. So we can write the here x is the displacement. You all know that what is x dot, it is the velocity, x double dot, it is the acceleration. Okay, then for three forces will be there. One is inertia force. Inertia force is equal, according to Newton's second law, m into acceleration. What is acceleration here? It is x double dot. The damping force is given as c into velocity, and stiffness is k into stiffness. So these are the forces that are acting. So you can see here, considering the equilibrium, there will be three forces. One is inertia force, one next is damping, next is stiffness. Then that will be equal to the external force. So here mx double dot plus cx dot plus kx is equal to f of t. Now we are considering f of t as p sin omega t. Omega I am written omega dash t. So since omega is represented as a natural frequency, so now I am just taking. So in some textbooks it may be omega dash, or in some, if some questions it is asked, for example you may be asked to find out the response, what is the equation of response, then sometimes it may be a omega double dot. So it will be given in the question, or you can choose if it is not given. The denotation can be, you can choose it. So first of all, let us look into so now we are studying about harmonic loading. In that, let us look into two conditions. One is undamped. Undamped means C is equal to 0. So the equation, we all know that. What is the equation? mx double dot plus cx dot plus kx is equal to f of t or p of t. Now here c is equal to 0. Therefore the equation will be mx double dot plus kx dot is equal to p of t, or this p here it is p0 sin omega t. So in the case of the solution, earlier we have studied the general solution will be x is equal to a e raised to lambda t or g e raised to st. Likewise only we have studied. Then we have found out what is s, then we have found out what is x, like that. Now in the case of that is the case of free vibration, but now we are going to study force vibration. So here our general solution x will be consisting of two solutions. X will be equal to xct plus xpt, where xct it is the complementary solution and xpt is the particular solution. And here complementary solution, this one depends upon the vibrating system, and this xpt depends upon the loading. So that is xct depends upon the natural vibration, that is a free vibration. For simplification, so our solution x will be having two components. One it is a complementary solution plus particular solution. So the sum of these two will be our general solution. Okay. So as you see, we will be getting more clear. Now xc of t, the solution it will be like this: mx double dot plus cx dot is equal to kx is equal to 0. That is our main equation. Is what is our main equation? That is it is written here. That is, so you can see this is our main equation, and it is having two solutions. In this, the first solution is xc of t. Xc of t, the general solution, we have to find out separately. Solution is given as a cos omega t plus b sin omega t. So this is our equation. Here you can see it is omega. It is not omega dash, it is omega. That is, so our general solution, this is our main equation. This will be of two types. That is, one is mx double dot plus kx is equal to 0. Another is mx double dot plus kx is equal to p of t. There are two. So that is the xc of t. This complementary solution depends on this equation. We have to solve this. That is, here we will be putting p is equal to 0, and xp of t, it depends upon this load. So that is written here. Complementary solution corresponds to vibrating system, that is the natural frequency. So that is the reason why here I am taking the general as omega t. So here how we can find out? We will be finding out the boundary condition and we can find out what is A and B. So we can find out what is the equation. Now here you can see x p of t is equal to, I am taking it as C. So this is our complementary solution. This is our particulate solution. So both these equations we have to solve. Then by adding up we will be getting the solution. So first we are starting xc of t, it is cos omega. In harmonic loading it is assumed that the motion is harmonic and the response will be in the form of harmonic loading. So you can see here, first of all we are going to find out what is xp of t. So let this be here. Now we are going to find out xp of t. For that we have to find out what is c. If I am able to find out c, so in order to find out c, I am having, what is the equation I am having? Mx double dot plus kx is equal to p sine omega dash t. This is my equation. So here I have now x, instead of x I will be substituting, here I will be substituting c sine omega dash t. What will be x double dot? It will be the double integral. So first integral, what is the x dot will be c omega dash cos omega t. Then what is the second integral? It will be minus sine. So minus c omega 2 times will be coming omega square sine omega t. So I am substituting this here instead of x double dot. So our equation will be like this. So you can see here the equation is like this. Here I am having, so here you can see minus m c omega square sine omega t plus kc sine omega t is equal to p sine omega t. Okay. Now here you can see, here I am going to take the constants of sine omega t separately. Here you can see this is the sine omega, everything is sine omega t. This is also sine omega t. So I can write this equation like this. I am taking the constants of sine omega t, that is c k minus omega square is equal to p of 0. So what is the equation which I have to find out? I have to find out what is c. So here you can see I am taking k as common, that is 1 minus m omega square k. Now you can see here what is m. So here you can see I am just expanding this. I am taking k constant k, then 1 minus m omega dash square by k. But what is m by k? Or we know that omega, natural frequency, is equal to root of k by m. So I can write omega square is equal to k by m, or here it is m by k. So m by k is equal to 1 by omega square. So I am, instead of this m by k, I am substituting omega square. And what is omega by omega square? It is a new term, that is beta. Just I am introducing some new terms, that is beta. Beta, it is the ratio of the applied loading frequency to the natural frequency. So natural frequency is root of k by m. And what is omega? The omega dash, it is the applied frequency. For example, if I am having a sine, for here what is the loading? It is p0 sine omega dash t. This omega, so it will be given in the question. It may be 2t, for example, the loading may be p sine 2t. So what will be the omega now? It will be 2, likewise. So here you can see, so I am substituting a new term, that is beta. So sometimes in the question you will be given this ratio. So instead of this omega dash by omega, I am substituting beta. So it will be beta square. So I got the c value. So xp of t is equal to p0 by k 1 minus beta square into sine omega t. This is the c term. Okay. So we started from here only. Xp of t is equal to c sine omega t. So from there we started and we found out c. So now I am writing. So this is my total solution, that is the particulate solution plus complementary. So this one, so I am expanding. So this is the way in which you have to find out the, first of all I found out what is particulate integral. Now I am taking the total solution. Now you can see here this is a cos omega t plus b sin omega t plus b0 by k 1 minus beta square sin omega t. This is my solution. Now I have to find out what is a and what is b. For that I am having the boundary conditions. That is, at t is equal to 0, at t is equal to 0, our displacement x is equal to x0 is equal to 0, because how the sine wave is going, it is like this. So at initially the velocity, that is 0. Then since velocity is equal to, since the displacement 0, therefore x dot will be equal to x0 dot, that will be equal to 0. Now I have two equations here. I can substitute, that is, you can see two equations I am having. First one, it is this is equation. Second one, it is the derivative. I am taking the derivative. So I will be getting a is equal to 0, and also here b I will be getting like this. Okay, so I have got a and b. I am substituting in this equation. So here you can see here this term, that is this term a is equal to 0. So this will be my solution. So I only have b. So b I am getting it like this. So I am finally substituting in the general solution. So I will be getting like this, and in that you can see I can take sin omega, this term b0 by k 1 minus beta square. This term is taken as common, and sin omega t minus beta sin omega t. So this is my solution. Okay. So this is my general solution. And here you have to understand an important term, that is, here this consists of two solutions, that is two terms. This is the first term. This one is the first term, and this one is the second term. So this first term, that is b0 by k 1 minus beta square omega t, this is known as steady state response. This is a very important thing. So this final x of t, it consists of two terms. First term, it is steady state response. Second term, you can see what is the only change here. Change is there is a beta term. You can see here only a beta term is there. That is known as transient stage or transient vibration response, and it depends upon the free vibration and will vanish completely. That is, I will explain that. For example, I am having a structure like this. Okay, the load is applied. What is the load? It is p sin omega t. This is a harmonic load. What will happen? It will vibrate. So during vibration, it will be having two conditions. One is transient, other is steady state. This transient vibration depends upon free vibration. Free vibration means that is mx double dot plus kx is equal to 0. No force. That is, this depends upon natural vibration, that is omega root of k by m. This is the vibration due to applied loading. That is, what is the load here? It is p sin omega t. So the generally we are having this is a general solution, and it will be having two terms. One is steady state response, other is transient state. Steady state response depends upon applied loading, and transient state depends upon the free vibration. So here this term will vanish. That is, after some time this term will be 0. So that is the meaning. So after some time, the first term will only be there. So that is the only thing you need to have in mind. So this is the way in which we can find out what is the response of a damped system to harmonic loading. Okay, so I am not explaining once more. You can just rewind the video and see. And you can see here you are having another term is there. Here we got this term. Here you can see a term, that is 1 minus. So in both these terms I am having a common term, 1 by 1 minus beta square. Okay, this term is known as magnification factor. Okay, this may be asked, that is, it is known as magnification factor or dynamic load factor or response ratio or deformation response factor. All these terms are same. So it is represented by 1 minus beta, 1 by 1 minus beta square. And what is beta? Beta, it is omega dash by omega. What is omega dash? It is the applied loading frequency divided by loading frequency, angular frequency divided by the free or natural frequency. What is natural frequency? Root of k by a. Applied it will be given in the question. Then another term is response ratio. So response ratio means it is the another term it is there. It is a convenient measure of the influence of dynamic loading. It is a ratio of dynamic response to the displacement produced to the static response. So response ratio, it is this x of t which we have studied now divided by x s t. It is the dynamic response to static response. Static response means the what that is, we all know that load is equal to stiffness into displacement. This is our general condition. So stiffness is equal to the displacement is equal to p by k. So this is the static case. So that ratio is known as response ratio. So just a ratio, that is. So now let us look into the next topic, that is in the last topic here C was 0. Now it is C is there, that is damped. So this is our equation. The change is here. Again, here it consists of two solutions are there, that is xc of t and xp of t. Two solutions are there. Okay, that is complementary solution and a particular solution. Now here you can see what is the change here. The last case, since here C is not equal to 0, so our general solution will be, last case it was a cos omega t plus b sin. Instead of that, another term is also there, e raised to minus theta omega t. Theta we have studied earlier. E raised to epsilon omega, this term into omega t. And xp of t was in the last one only, it was c, only one constant. But here, since damping is also there, we are having this equation, c1 sin omega t plus c2 cos omega dash t. So this will be our starting. So now we will be finding out what is c1 and c2. Then we will be adding to this. Then we will be finding out a and b. Same solutions only, but there will be lot of calculation will be there. So we can just start. So this is our xp of t. We will be starting from this. I am finding out this derivative x dot, then x double dot. Okay, just finding out the derivatives. Then I am substituting in which equation? I am substituting in this equation. Sorry, this is our equation, first equation. So I am substituting this x double dot, c is x dot and x in this equation, and you can see here. So this will be our general equation. You can see a big equation. In that, how we are going to solve it? You can solve. First, I will be equating the coefficients of sin omega t. So here you can see there is sin omega, here also sin omega is there. Then again we are having cos omega is also there. Here it is cos, again cos. So first of all, I will be equating the coefficients of sin omega t. So I am taking all the coefficients. So here what is the first coefficient? Minus some c1 omega square, that is written here. Likewise, I am taking the coefficient. Here what is the coefficient? Sin omega p0. So this is, so here you can see I am having the coefficients and I am just rearranging the terms. You can just write and look. I am arranging it in like in this format: c1 into 1 minus beta square minus 2 theta beta. Beta, the term is also coming here. I am introducing the term. What is beta? Beta is omega dash by omega. So I will be getting one equation. Let it be equation number 3. Okay. Next one, I am equating the coefficients of cos omega t. So cos omega t, here you can see it is equal to 0 because here I am only having sin omega t coefficient. So cos omega t in the LHS RHS it will be only 0. Again I will be getting another equation. Two equations I have got. Okay, you can see two equations. C in equations in terms of C1. Sorry. Here you can see equation C1 and C2. Okay. Again another equation C2 and C1. So just I am comparing these two equations. I can substitute C1 and C2 and I can find out from these equations, from equations 3 and 4, I can find out C1 and C2. Okay. Now I am having the general solution. I am just substituting it. So this is C1. We started from here only. So instead of C1, I am substituting this larger term and this term. Now I need to find out the amplitude. Okay, so here the last case, the undamped case is very simple, but compared to damped case, we are having lot of equations. But anyway, one thing you need to understand is that here we can see what are these two terms. Just look, C1 is equal to P0 into 1 minus beta square by K into a tau. Here also the denominator is same only. Okay, both the denominators are same only. Only the numerator, one factor is changing. So that is the only thing which you need to keep in mind. That is, here it is 1 minus beta. Here it is 2 beta theta. Okay. So just I am having these two conditions. I am just drawing the vectors and I am finding the amplitude. So the amplitude, that is amplitude, here you can see what will be this total equation can be find out. I am having amplitude will be like this. So what is the amplitude I need to find out? So that amplitude will be root of a square plus b. Amplitude will be root of this term, the whole square, divided by root of this term, the square root of these terms. So that is the thing which is written here, and I will be getting this value. Amplitude is equal to P0 by K into root of the top term. You will be simplifying. So this will be my amplitude. So and the phase will be like this. It will be 2 theta beta by 1 minus beta square. This is my phase. So phase means here you can see, here I am having one angle. So this amplitude. So phase means what is the angle it is making with one of the vertices. So here I am taking, this is the vertex. So tan theta I am taking, tan theta of this divided by here. If this term is same term will be here also. So tan theta of this opposite by adjacent. Same simple equations only. So the simple you can even if it was a larger equation, but what is the final result? It is a very small equation which consists of beta and theta. So this is the way. So this solution I have changed to this value xp of t, and in between okay, so that will be our solution. So here in damped case, you no need to study too much on that is that is like I can say here, that is here in the last solution we studied, we find out A and B. So here anyway that to that level you no need to study, just find out C1 and C2. So that will be enough for doing the problems and all, because a lot of derivations are there. So it will be better to only study up to what I am saying. So here you need to know what is the amplitude and all. It will be asked for the exam. Now another term is there, dynamic magnification factor. It is given by the amplitude A, that is it is the ratio of the dynamic response to the static response. So this we studied in last here also we have studied. That is in undamped case, it was like this. It was a very small term. Now in the damped case, it will be like this. A by P0 by K. A is the amplitude due to our main vibration. So what is A? A we found out here. This is A. Okay. So I'm just writing what is A. So A is equal to this A. That is a dynamic amplitude. That is equal to P0 by K into root of so it will be A will be A, we have already found out A, P0 by K into root of 1 minus beta square the whole square plus 2 theta beta. So this is not to be 2, it is beta square only. Okay, this is beta square. So this is dynamic application factor. Now here some conditions are there. When sometimes when beta can be 1, that is omega dash by omega. So then when beta, that is applied frequency, will be equal to natural frequency, that is that is, for example, omega, what is applied frequency? Omega root of k by m, that may be equal to the applied frequency. So that is here, when that theta term, that will be 0. So here two conditions can be there. When beta is equal to 1 and theta is equal, this is equal to 0, then d will be infinity. This is a steady state response which leads to resonance. This is a very important. What is resonance? Resonance means that is, if I am having a loading, that loading frequency will be equal to natural frequency. Then what will happen? The vibration will be, that is, dynamic loading means vibration. Vibration will be increasing to a very high range. That is, it lead to the destruction of the structure. So that is stage is known as resonance. That is why here so in resonance, what is the term? This dynamic, this is a magnification factor. That is, if, for example, if I am applying a static load and it is having some displacement, the same, instead of static load I am applying a dynamic load, then there will be also displacement. But when these two, the displacement, that factor is infinity. That what is the meaning of infinity? That is the magnification factor is infinity, means that will result in large vibrations. So such a state is known as resonance. Okay, so it is not good for the structure. The next condition, beta is equal to 1 and theta is equal to 1. Okay, then d is equal to 1 by 2 theta. Okay, so that is another condition is there, and in that condition, however, this is close to maximum and it does not reference the maximum response. Hence, I am just finding out what is the maximum value, d by d derivative, that is equal to 0. So just I am substituting and I can find out a term, that is, in this condition beta can be written as 1 minus 2 theta square. Likewise I can write. So just a condition, that is to find out the maximum. This is the maximum stage, and in the maximum condition, instead of this beta, I am substituting 1. What is I am substituting? Root of 1 minus 2 theta square. So I will be getting, this will be my maximum dynamic magnification factor. Okay, so these are the things which you need to know here. Now let us just look into a very small problem. So here a steel frame supported on a rotating machine which exerts a horizontal force. A horizontal force, what is a horizontal force? It is 50,000 sine 11t. So this is omega dash. Damping 4%. What is the amplitude of the vibration? Here you are given the moment of inertia, I is given and E is also given. So this is our condition. It is 4 meter long. So now you can see what is the equation. This equation you need to study. So here it is amplitude we studied. You need to know this equation only. A is equal to P0 by K root of, this is a denominator term only, this whole term. Now here what is P0? That is P0, you can see it is given, P of t is given as 50,000 sine. So from here I can write P0 it is 50,000, omega dash it is 11 radians per second. Okay, now I am having two, this is important, that is here I am having two columns. So this I can write like, this can be like this, there are two, this will be my model, okay, K1 and K2. So since it is parallel, what is the value? It is K1 plus K2. And what is the value of K1, K2? This one you need to understand. So here it is a pinned end. Then this K value is equal to, you need to know this K value. K is equal to 3 EI by L cube. This is the value, 3 EI by L cube. So here the E it is given in question, I is given, L is equal to, again it is also given 4 meters. So this value you need to see. This you will be studying in your structural dynamics, structural analysis, your main subject. Now that time you will be understand. So as of now, just understand this is the equation for the stiffness. So since it is parallel connection, I will be getting K, M, then omega. What is omega? Omega it is equal to root of K by M. I am substituting, then beta I am finding out. From that I can find out what is amplitude. So amplitude, just I can find out. Now next question I am just looking here. Determine the steady state amplitude for a horizontal motion of a steel frame shown in the figure. It's a steady state amplitude, and also you can see here damping it is not given. Okay, damping it is not given. Now here, since damping it is not there, so this term, you can see this is a term theta. See what is theta? This term, this is C by Cc, which we studied. Here damping is not given, that means C is equal to 0. So in this term will be 0. So what is amplitude? P by K, root of 1 minus beta square. So again I am saying one thing, it is P0 by K root of 1 minus beta the whole square. So this is my term. So since here beta the whole square, root is there, and I can simplify it as P0 by K into 1 minus beta square. So this substituting again from the load. Here the load is given. What is the load? It is given. It is here it is given. That is 10 sine 12t. So from this, our general equation is P0 sine omega dash t. So from here, what is P0? It is 10. And what is omega dash? It is 12. So that is the only thing. So here you can see it is here you can see it is omega dash and P0. Okay, now K, again there are 2K. Now here the K equation is K, it is 12 EI by LQ. In the last condition, what was the K value? It was 3 EI by LQ. So what was the change? That I am going to say now. It is here you can see it is a pinned support. Okay, what is the condition here? It is a fixed support. So when it is a fixed support, the K value will be 12 EI by LQ. And when it is a pinned support, hinge support, it will be 3 EI by LQ. That is, you just imagine which is the highest term. 12 EI. That is, anyway, for if I am fixed support, the stiffness will be very large. Pin support, it will be less. So this term, so that is a change. So that is why this question is discussed. The only change is this loading. According to this, what is a support? And for another condition I am taking. For example, the structure is like this. One end is hinged and other end is what is the condition? Other end is pinned. So here what it is K1? K1 will be 12 EI by LQ and K2 will be 3 EI by LQ. So that will be the change. So here since K1 and K2 are same only, so just substituting I can find out what is A. Okay. Now another question in a test on a single story building. I can see here a harmonic loading was operating at frequencies. Okay, there are two frequencies. Here you can see. So now you can see here. Here there is two harmonic loading. One is omega 1t and omega. So two types I am giving. Omega, I am just writing omega 1, omega dash, and two frequencies are there. It is given at 16 radians per second and 25. And in these two, I am having amplitude also. Amplitude and phase it is given. First amplitude it is 0.2 and the phase it is given as 15 degree. Okay. Next one it is amplitude is given as 0.45. Phase it is 55 degree. Okay. This is my condition. What is the thing I need to find out? Natural frequency and damping ratio. Damping ratio it is beta. So just you need to understand this is our tan. This one you need to, this we study. So tan phi is equal to 2 theta beta by 1 minus beta square. Now I am having two conditions. One is at 15 and 55 degree. So here you can see I don't know what is phi, theta and beta. I don't know both the equations. So I have two unknowns and two equations I can write. First one in terms of 15. So I am taking the first condition. I am just substituting. I will be getting one equation. Next one I will be getting another equation. Both the theta and omega are same. Okay. Now here you can see instead of here itself I am finding out what is beta. Beta is equal to omega dash by omega. So I am just substitute that here. I am substituting omega dash by omega. Here also omega dash by omega dash I know. That is here. What is omega dash? One is 0.2. Sorry, omega 1 dash it is 16 radian and other it is 25. So in both the equations I am just substituting. Two equations I will be getting. So I can just substitute and find out what is omega and theta. Sometimes you may be asked to find out. Here you will be find out what is K and what is M. For that sometimes K will be given, then mass will be given. So like this a question can be increased. So this type of question is in your model question paper also. This question was there, model question paper given in the syllabus. Okay. Now now let us know another question. Here a automobile which is having a weight is mounted on 4 identical springs. Due to its weight it sags by 0.23 meter. Each shock absorber has a damping coefficient of 0.4 Newton with a velocity of 3 centimeter per second. The car is placed on a platform which moves at a resonance speed having an amplitude 1 centimeter. Find the amplitude of vibration. So that is our question. So anyway, if a question is very big, but only you need to understand these terms. So we need to find the amplitude of vibration. Also, what is the equation of amplitude? That's the first thing we need to find out. P0 by K root of 1 minus. This is our equation. This is the thing which we studied so far. Now here, what are the terms? W, it is given 150 Newton. So I can find out M it is equal to 150 by 9.82. And what is K? K it is given it as, here you can see, here what is really K? K is equal to force by displacement. So that you can read here. When a force of 150 Newton is applied, what is the displacement? Sags means it is the displacement. It is 0.23. So what is the thing you need to understand? Here I am having an automobile whose weight, automobile is like this. It is having, how many springs are there? 4 identical springs. That is, here a spring is there, here is a, so if I am drawing the 3D view of this, here I will be having a spring, this end, 4 springs are there. So when I am having a load, it will be sagging by 0.23. So from that I can find out what is K. So now I have omega. Okay, omega is equal to root of K by M. So I find out omega. Next then it is the load. Load P0 it is 150 Newton. It is already given. Next one it is C. The C value, here you can see. How can I find out C? That is, it is having a damping coefficient of 0.4 Newton for a velocity of 3 centimeter per second. 3 centimeter per second. Now, what is damping? So, damping Fc is equal to Cx dot. So, this is given as 0.4 Newton. So, what is given? It is 0.4 Newton. So, why did they write like this? Because that thing you need to understand. What is mx double dot plus cx dot plus kx? This is our equation. So, this is the damping force. So, damping force it is given as damping coefficient of 0.4. So, this is the damping force. So, damping force is equal to c into x dot. So, velocity is given. So, I need to find out what is c. If I know c only, I can find out theta. What is theta? C by c dash. In this, what is critical? Critical it is equal to 2m omega, which we studied. So, this c depends upon this force. So, instead of, and here you can see 0.4 divided by velocity is given. Velocity is already given. What is 3 seconds centimeter per second. So, you need to convert it to meter, or you can convert into conveniently meter per second. Okay. So, it is 3 here. Then, why there is 4? 4 because there are 4 springs are there. So, from this I can find out what is C. So, from C I can find out what is theta. Again, just substitution I can find out. From here I can find out what is, here you can see omega is omega at, and here you can see What is the question? The car is placed on a platform which moves at a resonant speed. What is resonant? I have said that is when beta is equal to 1. What is beta? Omega dash by omega. So that is why. So in this equation, beta will be equal to 1. Okay. Now just substitution, I can find out what is the amplitude. So this is even if I have spread speedy, you just read the equation and write down the main equation. From that, just find out what are the terms given. So here the new term which we introduced is this force only. That is the only term which is introduced now. That is how to find out C. Okay. So I think all the types of problems, we have covered 4 types of problems, and from this 4 types of problems itself you will be getting the maximum questions. Okay, all different types of problems are explained. Okay, so that's all for this class. Thank you.